So that's what it means. If I print out number, I'm not printing out actual the number word, but I'm printing out the content of the number. You know that this bottle contains what? I get it. It contains what? But is it the only types of container that can contain water? Is it the only container that can contain water? Today's video is based on data types and variables, or variables and data type. If we say variables and data type, what is the meaning of variable? I guess most of you who've been to school know that since grade 7 or grade 6, we've been hearing about variables. But in real sense, what variables are? When it comes to programming, variables, they are just like containers. They are containers in computers. Like the containers we have in our real life, bottles, cups, the AutoCAD, buckets, you can say barrels, all those ones, they are different variables, and they are containing different items. So in this case, again, the same thing in computers. They have variables, and different data are stored in different variables. But how the computer will know that this variable is for these types of data and this variable is for these types of data? Are you getting it? All right. So let's conceptualize it. First, before conceptualizing, let me give you all the types of, like, the 8 types of primitive data types we have. Though we have different types of data, variables. We have primitive, different types of data types. We have the primitive and one non-primitive. But anyway, we will go to that. Don't worry. But let's see this. If you go to, let's say, W3 school, we can see that these are the types, 8 types of data types we have, meaning the modes in which data can be stored in our program, in our computers, right? So in this case, we have byte. Byte means if you have any data that will be not in less than 127, or not in greater less than negative 128, you can store it as what? Byte. We have short, we have integer, we have long. All these types of data, they are whole number based data types. You can see that stores whole numbers from negative 28 to what? Like if I have data that I know that they will not be greater than 27 and also not less than negative 128, I can store it as byte. Are you getting this? So let's see this. Before going to that, we have byte, we have long, we have int, we have float, double, boolean, and character, and you can see their sizes. This one is 1 byte, 2 byte, 4 byte, 8 bytes, 4 byte, 8 bytes, and we have 1 bit and also 2 bytes. So this kind of data, come on, still very confusing. Anyway, let's see this. If we have this one, we know that contains different things. But again, if I have show you this one, this bottle, we know that this bottle contains water. Are you getting this? It contains water. But is it the only types of container that can contain water? Is it the only container that can contain water? No. There are other containers also that contains water. We also have this. It contains water, right? So if this one can contain water and this one can contain water, what is their difference? You already know. Their difference is what? Size, or the volume they can contain. So that's the difference between when we say the whole number types of data, like the one we have here. Oh, come on. The one we have here, byte, all of them, they contain whole numbers. Short, they contain whole numbers. Integer also contain whole number. Long also contain whole numbers. But what is their difference? The difference is this volume, or the size of data they can contain. You can see that if I have data that are that are between this range, I can use byte. If I use short for that data, I'm wasting memory. What does that mean? Okay, let's see this. Okay, here I know that this water can be within this container. Are you getting this? This water can be within this container, this glass, but I choose to use this bottle instead of this. If my choice is only based on size, not other criteria, is only to contain this water, then I'm wasting space. Why wasting space? Because this bottle, instead of using this, I'm using this bottle to contain the same volume. It's a waste of space. It's a waste of space. I getting this? So I can just put it here rather than to put it in this bottle, because this bottle is 1.5 liter and this one is around, maybe let's say that 0.5 liter. I getting this? So it's a waste of space if I choose this bottle to contain the same volume which this cup can contain, right? So that's what it means. Now that's the difference between reason why we are choosing byte instead of sort, or sort instead of byte. If I know that the data is greater than 1 byte, I can go to sort in terms of whole number. If I know that the data is greater than 2 bytes but less than 4 bytes, then I can go to int. This it. Now how about choosing sort instead of int when the data is greater than 2 bytes? That's exactly what he's talking about. Now look at this. Let's see this one. Look at this. If I take this amount of water, this volume, and want to pour it in this small cup, what will happen? Overflow, right? As you guess it, overflow. It will overflow because this volume cannot fit in this small container. So that's what we have, and the same error the computer will give you. Let's see this. I have byte. Let's say byte data called number and equals to what? Let's say 300. You see this? There's an error. Look at the error. Cast expression to bytes. Let's see this. What do you have? There's an error because in this case I can provide it as int. More. Change the variable number to type int. Split the declaration and what assign. So in this case there's a problem. Look at this. If I want to system.out.println, come on, and want to print number. If I print this number, this one is what possible lossy conversion from int to bytes, meaning it's giving me hint. I get incompatible types. Why incompatible types? Because this 300 cannot fit in that size. It's overflowed, right? Is overflowed. And if you look at this in the when we go to W3 school, you can see that byte can store only numbers between negative 128 to 127. So I cannot use data that are greater than that and store it in bytes. It will be a problem. But I can store it in sort. Let's see whether if I change it to sort, the error will persist. The error will still persist, or the error will go. Let's see this. If I change the data type to what? Sort. You see, the error have gone because sort can contain those data. And look at the let's look at the range of sort. What is the range of sort? The range of sort data type also store the same whole numbers, like it stores the same water as the bottle and the glass, but its size is negative 32,768 to 32,767. Any types of data, any types of number that is between this range, I can store it in sort. I mean any types of whole number. Again, if I want to store millions, I can store it in sort. I have to store it in int because int is greater than that. You can see that million is less than this. This one is, it can only store what? Thousands. Are you getting this? It can only stores what? Multiples of thousands. So that's what you have. Now in this case, when you are dealing with something like this, if you are dealing with another data that is going to billions, again trillions, I cannot use this, but I have to go and use long, because long is that type of data that can store it. You can see that both long, byte, sort, and int, all of them can store the same type of data but in different size. When it comes to again float, double, and float and double, they can store the same types of data but in different size. Are you getting this? The same thing, float, and the difference between float and these whole numbers, those who know at least basic math, you know that integers, they are only whole numbers, while double data types, or you can say that while decimal numbers, they are rational numbers, they are what they involve decimal parts, right? The same thing here, double and float, they are dealing with decimal points like 2.5, 2.6, 2.7, pi, other stuff like that. They are what either float or what or long, right? So that's what you have in this case. If you come here, IntelliJ, and want to store this data, let's say that to 300.5, there's an error. Look at this. Why error? Because 300.5 is not an integer. You can see that sort, byte, all of them, they are whole numbers, but 300.5 is not a whole number. So this is the error it will give us. You see this sort will tell the computer that I'm expecting data of whole number. One, that's the type. And second, also I'm expecting this size of data, that is between 32,768 to 32,800 and what 67. So this kind of data, that's the computer expecting. That's what this sort is. What's the importance of that sort? A number, the important is giving me the label of the address in which that data is stored, so that whenever I want to print or do any manipulation, it will go direct to that address and do what? If it goes to the address, it will what? Print the content of that address, not the container itself. Now in this case, what I do, if I print it out, you will see something there. You will see 300 instead of number. I'm not printing out number. You can see that I'm not printing out number. What I'm printing out, I'm not printing out 300. I'm printing out number. So why it print out here 300? It goes to the memory address called number and take its contents, print it out to the console. So that's what it means. If I print out number, I'm not printing out actual the number word, but I'm printing out the content of the number. Are you getting this? So these are different types of data, and today we treated these four, which is what? One, we have byte. Two, we treated sort, and four, which we are for int, and third, which is what? Long. Long, again the same thing. Long is 8 bytes, but still whole number. Okay, let me just put it here. This one is what? 4 bytes. This one is 8 bytes. Sorry. This one is what? 2 bytes. And this one is what? Is 1 byte. These are the what different. If I have a data that is less than 1 byte, 1 byte mean what? 8 bit. Or another data that is what? 16 bit, which is 2 byte. Another data that is 2 bit, another data that is 64 bit. Then I have to what? Choose them differently. Again, I can store 1 byte of data, like let's say a 10 in a long, which is 64 bit data, but it's a waste of space. Why choosing long instead of what? Why should I choose long? Because long can store what? It can store 64 bit of data, can store 10, can store even 0 or 1, but it's a waste of space. It means in real life, let's see that one. It means in real life that taking this bottle, like let's say a cup small as this, water, then store it here. I get in this, where it can what? Use a space that is actually equivalent to this or less than that. So that's what it means. So choosing one here, it depends on the type of data it is. If the data is less than 1 byte, just go to bytes. If it is greater than 1 byte, go to sort. If it is greater than sort, go to int. If it is greater than int, go to long. I get in this. So this is the what? Different types. But actually, don't be confused. All of them, they are containing the same types of data. We will talk about all the different types of data when it comes to our next session. Thank you guys. This is the starting and this is the logical explanation which you can apply to any programming language. I'm not only using Java, but even if you go to AutoCAD or either C# or C++ or C, any programming language you are using, this is the concept you're going to use and still it will work. Are you getting this? So see you later next session. Thank you guys.